Hello everyone, welcome once again to today's practical class. In our class today, we'll be looking at the topic equilibrium of forces. We'll read the instruction, set up the experiment to take our readings. It says, you're provided with two rotor stand, force board, clamped pulley, set of masses, thread, and other necessary material. Using the diagram below as a guide, carry out the following instructions. 1. A thread WY fixed at pulley W passes over pulley Y on a force board and carries an unknown mass M0. Retain this mass M0 throughout the experiment. Draw a line along the direction of WY on the paper held behind the thread. Locate the midpoint X of YW and mark its position on this line. Draw XN at right angle to WY. By means of a loop of a thread, suspend a mass M equal to 50 grams from WY and adjust the position of the loop so that the line of action of the weight of M lies along XN. Ensure that M and M0 hang off the force board. Measure X0 equal to Y and W0. Evaluate Y over W. Repeat the experiment for M equal to 70 gram, 90 gram, 110 gram, 130 gram respectively. In each case, determine the corresponding value of Y, W0, and Y over W0. Tabulate your readings. So first of all, we draw a line here, draw a straight line here from this point to this very point. So here becomes our W from the instruction, while here is Y. So we measure this line to get its midpoint. Its midpoint will be at 14.5 and here will be X. Then we draw a line down here, a perpendicular line down here. This is in line with the instruction given, okay, where here is N. This is the M0. So this is a fixed pulley, while this is a movable pulley. So it will pass through here. This is mass 50 gram. So we place it here. We'll move it to the midpoint. And here is the midpoint. So we'll mark our point here. So the next is 70 gram. This is 50. If we add 20, it becomes 70. I'll add it here, hang it here, shift it to the center. This is the midpoint. Once I get to the midpoint, I'll use my pencil to mark. After 70, it is 90. So I'll add this 20 to make it 90. If I add it here, I will allow it to move. I'll shift it to the center, and that is the midpoint. I will mark my point here. After 90, we'll have 110. So this is 20. If I add it here, it becomes 110. I'll allow it to move. I'll take it to the midpoint. I'll take it to the midpoint, and I'll mark my point. So the next is 130. I'll add 20 here to make it 130. I'll shift it to the midpoint and I'll mark my point here. So I'm done with the experiment. I'll bring this down. So I'll take my meter rule and I'll draw a line from here to here. I'll draw a straight line from here to here. Remember, this is for 50 gram. So here is 0. So let me measure. For 50 gram, we have 50.0 So I'll measure for y. From here to here is equal to y. So my y is equal to 3.80. So I'll write 3.80. I'll measure W0. W0 is from here to here. And W0 is equal to 15.00. So the next one is for 70 gram. I will draw my line down here. So for 70 gram, W0 is equal to 16.50. So I'll write 70.00, 16.50. Then I'll measure Y. Y is equal to 7.5. So here is equal to 7.50. Then I will draw the next one, which is for 90 gram. For 90 gram, W0 is equal to, let me measure it again, 19 cm. So here is 19.00. I will measure for my Y, which is from here to here, and this 11.70. So here is 11.70. The next is for 110. So I'll draw my line down here. So for 110, W0 is equal to 1221. So 110.00. We'll have 21.00. Then I will measure here. My Y is 14.80. So here is 14.80. And the last is 130 gram. So I'll draw my line here. 130 gram. So here is 130 gram. I will measure for Y. Y is 17 cm. So 17.00. Then I'll measure here. Here is 22.5. 22.50. Remember, this paper is very important because you must submit it after the exam. Then the next says we should evaluate y over W0. That is, we divide the value of y with the values of W0. 3.80 divided by 15, 0.253. Then the next is 7.50 divided by 16.50. That will give 0.455. So, and the next is 11.70 divided by 19, 0.616. 14.80 divided by 21, 0.705. Then we have 17 divided by 22.50, 0.756. The readings gotten from the instrument given, we leave them in 2 decimal places, while the calculated value, we leave it in 3 decimal places. We are asked to plot a graph of y over W0 on the vertical axis and m on the horizontal axis. So I will draw my vertical axis. I will draw my horizontal axis. Is to choose a scale. Remember, in choosing our scale, we choose a scale so that the plotting will cover 1/3 of this graph sheet. Looking at the value for mass, the highest value is 130 and the lowest value is 50 gram. So let's see this axis. The highest value here is 0.756, while the lowest value here is 0.254. So we can take it from here. The box here is equal to 2. 10 box is equal to 20. 2 boxes will be equal to 50. So we count 10, 20, 1, 2, 3, 4, 5. So 50 is here. And now look for 0.253. I'll say 0.2253 divided by 0.01. And that will give me 25 boxes as well. 10, 20, 21, 22, 23, 24, 25. So it is at this point. So here we now look for 70 gram on this axis. Remember, one small box is equal to 2. So to get 70 gram, we divide 70 by 2, and that will give 35. So 10, 20, 30, 31, 32, 33, 34, 35. So 70 is here. So to get 0.455 on this axis, we divide it by 0.01, and that will give 45 boxes. So I will count 10, 20, 30, 40, 41, 42, 43, 44, 45. So it is at this point. So I will join the line. I'll mark my asterisk here. The next is 90. I'll say 90 divided by 2. Of course, that will give 45. 10, 20, 30, 40. 45 is here. Against 0.61, that will be on the 61 box. 10, 20, 30, 40, 50, 60. And this is 61. So I'll mark my asterisk here. The next is 110. I'll say 110 divided by 2, and that will be 55. So 110 is here against 0.70, and 0.70 is here. So which means I'll mark my asterisk here. And the next is 130 against 0.75. 130, here is 130. 0.75 will be 1, 2, 1, 2, 3, 4, 5. I'll mark my asterisk here. So I already have 1, 2, 3, 4, 5. The next is to draw a line of best fit. And that's a perfect line of best fit. The next instruction says we should calculate slope. So I'll draw my slope. Then I'll write change in y over w 0, change in m. So to calculate the slope, I will write slope is equal to change in y over w over change in m. 0.93 minus 0.2 divided by 100. So slope is equal to 0.0073. Then the next is state precaution taken to ensure accurate results. Number 1, I noted 0 error on the meter rule. Number 2, I avoided error due to parallax when taking reading from the meter rule. And the next question says, distinguish between resultant force and equilibrant force. Resultant force is that single force which acting alone will have the same effect in magnitude and direction as two or more forces acting together. While equilibrant force, that single force which will balance all other forces taken together. The difference between these two forces is that they have the same magnitude, but they are in opposite direction. So the next question says, state two conditions necessary for the equilibrium of three non-parallel Copeland forces. The conditions are: number one, the vector sum of all the forces acting on the body must be zero. Then number two, the sum of clockwise moment about any such axis equal the sum of anti-clockwise moment about the same axis. If you follow this step, tabulate your readings, leave them in appropriate decimal places, write your units, plot your graph, evaluate the slope, and answer the questions thereafter, you are sure of scoring the 25 marks that is meant for practical class. Follow me for more videos on practical physics. Bye for now.